Okay, so now it's recording. And hopefully you managed to watch the Neil's video on the molding and casting before this one, but I will just really shortly go through what he was presenting. Basically, in the molding and casting week, he presented first different types of molding, and this injection molding is the way to make most of the materials that are made in the molding. It's very common and very fast way to do plenty of things.
You are not sharing the screen. I don't know if...
Sorry. I forgot to put that one on. Yeah, now you should see. Yeah, this injection casting. It's the way to do these so many different types of parts. Basically, whenever you can create a mold, you can also injection cast it. It's a very flexible way to produce things. Then there is one thing that is interesting is the one that for example, if you are planning to do some, if you have ever visited chocolate factory and you have seen these Easter eggs, how they are made this kind of roto casting. The mold is rotated around, and while the material is curing, and the end product is basically a shell with empty inside. So if you have, for example, eaten these Kinder eggs this Easter, it's how this is made. Then there is the vendors for different materials that you can cast, and we are going to probably use this Smooth Seal 940 as you are working from home. This is quite safe material unless you try to cause harm with it. It should be safe, and it's also food safe, so you can cast chocolate in it. For example, really nice example is Jari's work from 2017 when he was doing his chocolate chess pieces. Basically, he created the mold, then he milled it, and then he casted it with this Smooth Seal 940, and he produced this silicone mold, and then he cast chocolate in it to produce these chess pieces. So it's really nice result with this material. Then there is this Umu 30. It's also very commonly used. It's I would say it's a little bit harder to cast than the Smooth Seal 940. There tends to be a little bit bubbles inside unless you vacuum it really well. With Smooth Seal also you need to vacuum it, so you remove the bubbles with the vacuum. I will come to that a little bit later. Then there is the casting materials. For example, this Smooth Cast 305. This is something that is used a lot in Fab Lab. This is urethane-based material, and it produces quite nice results, hard pieces. As you can see in here, you can see the technical data of it, how to mix it in volume, how to mix it by weight, what is the pot life, what is the cure time, and things like that. For all the materials, you have these listed here. So basically, if you follow the instructions, you should be able to create nice things. And also on this website, you can find these videos about how to use these materials. It should show the video here, but for some reason it's not showing it. Now. I will skip a little bit. So you mix it in here by weight. And there you can see he's mixing it for 2 minutes and then he puts it in vacuum. We have the exact same vacuum system at the university. So you can see it expands quite a bit. So you need to be careful when you are casting a material. And it's this material. And then there is something casted inside it. So this is the Smooth Seal 940. It's really nice material and really easy to make high quality molds. And one thing in this course, in this week, is the group assignment where you need to go through safety data sheets for each of your molding and casting materials and then make and compare test casts with them. So in these material pages, they also have these safety data sheets. And these safety data sheets, for example, for Smooth Seal 940 and Oulu 30, they are the same. So same things apply for them. And you can see it's not a hazardous substance or mixing. And basically, if you use it according to instructions, you should have no problems with this material. With this smooth cast materials, they need to be operated in well ventilated places because they have harmful materials in them. So you can see it has lungs and skin irritation, so or respiratory, and you should be careful when you are using these. And this is why at the moment, if you plan to do it at home, this is not recommended. Basically, you can do your parts with the chocolate. Then you have basically the mold in the mold making. Well, I could actually go a little bit through before. We are using this kind of machinable wax to produce the positive mold for the silicone casting, which is the negative mold, and then you cast something in it to produce the final part. And the size of your piece is about the same as in this. And when you are designing your whatever you are willing to cast or mold, you should operate within these measurements, so it won't be too thick for the mill. We are going to use the SRM 20 mill, and it cannot reach down in the Z-axis more than this. So basically, that's limiting for thickness. But of course, if you are creating two-sided mold, then you can create double the thickness. So you can create bigger parts, but you need to design the mold in a way that you can actually produce them. So it's about 38 millimeters in thickness, in width 76 millimeters, and in length, well, I would say about 15 centimeters. That's good estimation. So you will have some space. So when you are creating this mold, machining this mold, basically you are doing the design in CAD. Then you have STL file, which you will put in the Roland's program, the play. This is so hard when it keeps dropping down. Modella Play 4, yeah, that's the name. And then you are milling it, and after that you will do the silicone cast in the mold, and in that mold you will do your part casting. So that's the whole process. And basically your individual assignment is to design a mold around the stock and tooling that you'll be using. So you need to decide what kind of tool you are going to use it to mill it with, and you have to design the mold in a way that your milling bit can actually reach every part. We have these long milling bits that are 3.18 millimeters in diameter, which can be basically used to make your whole thing. So you can only do it with one milling tool, and you will save a lot of time when designing the mold. So you don't have to actually think about the curvature of the parts and things like that. But milling has to have at least rough cut, and then at least 3-axis finish cut. So it needs to have both the roughing and the finishing, but the finish cut has to be at least 3-axis cut. So basically you need to have some curvature on the material. I will explain a little bit about that later when I'm showing you an example about it. And then you use your mold to cast parts. And as you are probably using Fusion 360 to do the parts, it's similar than I will be showing with the Inventor. But basically, you should start by reviewing the safety data sheets, so you will understand how to proceed with these materials and use them in correct ways. It will tell you if you need to use some sort of protective gear or not, and what are the temperatures of the curing and things like that. So that's something. And when you are designing a mold, you should think about whether you can cut it from the up position. Basically, you should have already done the CNC designs, so you should know about this a little bit. But in the mold making, you can create double-sided molds or even more-sided molds. If you didn't watch the video, you can see this guy. He was creating this with the molding, and basically he created this 5-sided mold and then cast it in it, and he produced this. So you can have more than 2-sided molds, but it takes a lot of time to design. Basically, the minimum is 1-sided mold, and it's really easy and fast to make. But I would, in a sense of learning, I would highly recommend you doing 2-sided molding. 2-sided mold, yeah. So when you are doing the part or designing the part, you should decide how to cut it in a way that you can actually mill it and then cast it. In this material, there are quite nice instructions for simple things and how to cut them and what other things called in the milling bits and what kind of milling bits can be found. For example, if you are doing the rough cut, you should always use the square-ended milling bit. And if you have some curvature on the surfaces, you can use ball-nosed. Typically, these are the two tools that are used for this task. This square end can also be used for the finishing, and it will produce quite nice results. So you don't necessarily need to use the ball nose milling bit. But if you use it for rough cutting, you will have these kind of curves on next to each other in your surfaces, and the end result won't be as pretty as it would be with the square end. And one thing is to consider the reach of your milling bit. Basically, you should design the mold in a way that your milling bit will reach all the way to the bottom without hitting the mold side. It will push the mold or the wax off the surface if it does this, and then you will ruin your cut. And if you need to make these deep cuts, you can use this kind of angled walls. For example, when I was creating mine, I can show you what happens when you do it in a wrong way and how you can then fix it. In here you can see that basically the milling bit hit the wall and it pushed every time a little bit the block away, and then eventually it came loose and stopped milling correctly. And then I changed the design in a way that I calculated the angle that it has to be at least 10.386 degrees for it to for my milling bit to reach all the way to the bottom of the design. So I did this. And then you can see in the final result that it actually cut it really nicely after I made the change. In here, the milling bit got stuck in the wax. I obviously put too deep in the material. So you can, with this wax, it's good that you can always melt it and then just recast it, and you can create these parts. In here you can see this kind of material, you can melt it. That's why we are always collecting the dust, because you can, here you can see when it's molten, then it starts to cure and it produces new wax block. And you can create different sizes if you have different molds. In Fab Lab we have the kind of bread mold that is used to create these certain sized pieces. And that's about that. I think other things are just general CNC stuff, so I won't go into that. But with this Saverio Silli, he has made nice video about molding and casting. He's the guy who also created the rotocast machine. So he really enjoys doing this, and he has nice instructions if you are interested in more materials. And I will start. Well, let's see if there is actually something. Well, it looks like this when you machine it. You can run it quite quickly as it's really soft material, but it produces really nice finish. So it's really smooth surface, and and your parts will look really good after you cast them. And here he's casting some kind of silicone in it, and there is the final product. And one thing that we like to also do every year is metal casting. And last year, Lucas was really enthusiastic about it, and he wanted to do this kind of Witcher medal out of metal, and we did the metal casting with him. So basically he milled the wax, then he created this silicone mold for it, and then he casted metal in it, and then the final product looks quite nice. So also an option is usually that you can also produce these kind of metal molds or metal casting. You can also use plaster to create molds for metal casting. And nice thing about plaster molds is that if you throw it in the water, it will melt away and only leave you the block of metal after it's melted. And you can create really high detailed molds with this as well. And we did this with Gleb a couple of months ago, and we produced this ring in Fab Lab, and it's really nice detailed piece. Okay, I will start showing you. I will first show you how to create simple one-sided mold, and then I will show you how to create two-part mold. So you can, in the sketch, you can just create something. I will just create centered rectangle, maybe 40 millimeters times 40 millimeters. Then I can just create the extrusion of it. Let's say it's 30 millimeters thick. I'd say okay, and then you can create the shell of it. So you can, if you select this one, your dimension will be a bit different. But if you choose this one, it's using the outer dimension as the starting point. But it needs to be quite thick because of the drafting we are going to do. With the draft, you can actually automatically create this this wall angle. So you can select, for example, for example, 12 degrees, which is enough for the cast, enough for the milling tool to reach all the way to bottom. Then you can apply. There was something obviously wrong in the draft. It's not the correct one. Yeah. So basically you can create this mold edges really easily with this kind of slopes, and it makes it a lot easier to create anything. Then you can create, just put your path, or you can actually design this also around your path, but let's say this is then 30 millimeter piece. It can be something simple, for example. Of course, it cannot be as high as the mold, but let's say 25 millimeters. And now you have this piece in the mold, and because this has to be at least 3-axis finishing, you can, for example, create 5 millimeter radius fillet around it, and you will have this part. So this would be, for example, one-sided mold that is already acceptable, for this course. So it's really simple task if you have no ambition. But if you have more ambition, I recommend you doing the two-sided mold. Basically, you can start it with the exact same thing. Let's say 20 times 20, and I will make it a little bit bigger so it will be more realistic, maybe. Yeah. Okay, then just same things. It can be 12.5 as well, it doesn't matter that much. But you should minimize the size of the mold so you can aim it with your milling tool. For example, if you are using the 3.18 millimeter tool, you can create the difference between path and this wall to be the 3.18 millimeters. Let's do something simple. Yeah, this time I will produce 25 millimeter path. Of course, if you have more complicated path, you have to think about it a little bit more, how to do your design. Then you can, for example, you need to have the hole to in one-sided mold. You don't need anything else but this, because you are pouring the material from the top. In two-sided mold, you need a hole to create the pouring of the material. So you can, for example, just create simple line. Of course, it has to be a little bit inside the wall, as there is the curve. And I like to use just this rectangle, because it makes it really fast to create. And it should be as thick as possible. Basically, the better the end result is, the bigger the hole, because it will the material will pour in more easily, and it also removes air out of the part. If you have more complex part, you can also create a hole to vent air outside of your part from another corner. It basically needs to be, of course, in the same side as your pouring part is, as it will otherwise the material will flow out of it. So you can just extrude this, for example, let's say 5 millimeters, and you have your pouring hole. And if you want to make it look a little bit nicer, you can of course then just fillet it a little bit, so it will look a little bit more like actual thing. And of course we can do this as well. And now basically you have the other side of your mold. And one thing I recommend doing at this stage is basically to mirror this part. So you mirror the whole thing and you select the mirror plane, and you have the part here. Of course, if they can also be separate from each other, it might be more clear. It doesn't have to be, because if you can do the both sides at the same time, you can also do it like that. And then, because you want to aim your molds together more nicely, the easiest way, that is definitely not recommended by Neil, is to create something, this kind of like, how to call it, like these small buttons that will fit inside each other. And then of course you can just either copy paste them in the other one. You can just create a sketch, new sketch for this one, then copy paste it here and move them in the correct position. Or there is also, well, I think I won't show the other way because it's a little bit maybe a little bit too messy way. Basically, you just have to aim them in the right spot. Otherwise, they will not be set in the correct way. Let's see. Of course, that's not in there, so yeah, it's 6 millimeters off of that wall. So you can select the whole thing and this, and let's create the dimension. It's easier that way. So you can move it there. Then it matches the other one. And then you can create the extrusions. The other one has to be male and the other one has to be female. So they will fit together and create single part. And now when you cast your silicone in this one, these parts will fit together and they will be almost like snapping together, and you can position them more easily. This is not the most stable way. Neil always prefers using this kind of parts that actually just
I think it's in registration at the
sorry.
top. Yep.
Yeah, this one, yeah. So they basically just snap together and form a single part. It's a little bit harder to design this type of molds, but if you are planning to use it multiple times, it's recommended to do it this way because it will stick together nicely for a long time. With this one, it will slowly start to move, and when you move it, it will snap these out, and also they can move a little bit on top of each other because the rubber or the silicone is so soft. This is basically the things that you need to know for that part. And I think you now should have possibility to remotely do the, here is one example as well. Yrjö was using wood to make his own mold. That's also a possibility. But you can see the finish is not so clean as with this milling wax, machinable wax. So you should get the access for the machine, and Mikko will set the things up in the locally, and you can remotely do the control of the machines. There are a few ways to do this. I'm not sure which is the smartest one. With the Modella player, it's really easy to produce the milling files, and you will find good instructions in all the sites in the previous years. Basically, you need to set the orientation in a correct way, and you set the starting point, or also in this case in the lower left corner, and you take out the margins. You set the roughing. Roughing is to remove all the excess materials. It's not going to be finished. And in this program, basically, you can click next until you have to choose the tool. And in this case, I highly recommend you using this tool so you don't have to change the tool between the cut. So you can run the whole thing, roughing and finishing with the same tool. And then just click next, and in here you select the upcut, and in here these parameters are one thing. In here you need to select the material, and in this case it's the modeling wax. And in the machine there is already settings for this modeling wax, and then you don't have to actually change anything in it unless you really want to. And it will calculate you the cutting path for roughing, and then you can do similarly to CNC. You can preview cutting in simulation, and it will show you how it will look at that stage after roughing. And then you create finishing. I was using this fine 0.79 millimeter tool, but in your case, in this situation, I would highly recommend you using the 3.18 millimeter tool. So you can scan lines either in X direction, in Y direction, or in X plus Y directions. And all it does is it runs first in the X direction, and then it runs in the Y direction. And the end result is a little bit smoother if you scan in the both ways. But in many cases, depending on the details of your product, it's already nice enough with either X or Y direction scan lines. But you should always think about how the milling tool is going to move in the material, because it cannot necessarily go behind every small detail unless you are doing the X plus Y tooling, milling. So also in here you have all the settings for the modeling wax, for smoothing, for this finishing, and you will see in here finish margin is 0 millimeters, so it will be the exact size of your part that you have designed. In the roughing, you have 0.2 millimeters in it. And basically, you set up SRM20 in the same way as you do with electronics or anything else. And you can either start your program through the Roland Model Player 4, or you can start it from SRM20. When you are creating this output, when you press the output process, it will ask you if you are going to output it in a file or in the machine. And if you put it in the file, it will automatically create you the NC file for the Roland machine. And in that case, you can, when you select the cut, you can select both parts, both codes, the roughing and finishing at the same time, and you can run it all the way through with one single run. In this case, it's sometimes, even if you have the same tool throughout the whole process, it sometimes stops the machine after output is done for roughing. I'm not sure why it does it, but it does it if you do some selections in a certain way, which basically is not something that is easily done if you intend to do it, but it happens sometimes. So the finalized product is very nice, and then you move to silicone casting. And if you are planning to use it with SmoothSil 940, as we highly recommend because of the situation, you can do this at home, basically. So you measure the amount of part A and part B and mix it. You have to mix it really well so it will be evenly colored. And then you put it in vacuum former. In this case, if you don't have access to vacuum former, you can also just pour it, and basically you can help out the bubbles. For example, if you have a toothpick or something like that, you can paint the surfaces with the toothpick, and it will help it cure on the surface. So at least the surfaces will be clean, even if there might be some small bubbles inside the silicone. But based on my experiences, this Smooth Seal 940, at least when it's new, it will remove the bubbles automatically quite well. I think I have never gotten any bubbles on the surfaces of these molds with this material. And after you have gotten your silicone parts, you can cast, for example, chocolate in it. And I created these little chocolate motors for my molding and casting week. I can put, for example, this link in the chat, how to add. If you are interested in seeing how Saverio Silli is doing it, it's quite nice. And here is something to think about the tool sizes and the tools and how to design your mold. I think this is basically what this week has in it. And if you can find, for example, a way to create milling files with Fusion for SRM20, that's also something that would be really nice. So you would only have to send the file to university and then just operate with it. And there is also in mods you have program for 2.5D milling with SRM20, and there is also the connect part. So basically you can also create milling paths with mods. It's of course a little bit different, but it's somewhat similar than the milling in, for example, in the outline milling of your PCBs. So you have the tool diameter, cut depth, and max depth. So you can select how deep you want to go in the materials and things like that, and it will produce the milling file for the Roland. So basically this is one option as well. The Roland player, Modella Player 4, it's probably the easiest way to produce these files, but you can also think about different ways. Is there any questions at this stage? Is it clear what you need to do? You can stop the recording.